Hello students, welcome to the class. So here we are going to start with our discussion on the second topic of first PUC chemistry, that is structure of atom. What all we'll be discussing here is we are going to explore the inside world of an atom here, which is fully, you can say, it is of mystery and surprises. We'll see so many different theories here. Whole chemistry is based on the atoms and their structures. You'll get to know how, and some of the points you have studied even in Dalton's atomic theory also. Apart from that, we'll also study the behavior of atoms, electrons exhibited by the electrons, and what are the consequences of that behavior, right? Now, when we talk about structure of atom, the question comes, why the structure of atom came into consideration? Why actually this came into consideration? See, Dalton had given the theory in the previous topic itself. We have discussed theory called Dalton's atomic theory. When scientists across the world perform a few different set of experiments, they came around the questions. There were many criticisms done on this theory, Dalton's atomic theory. Dalton's atomic theory, or you can say John Dalton, he was able to explain law of conservation of mass. He was able to explain law of constant composition, law of multiple proportions very well. But this theory, it failed. It failed to explain the results of many experiments. Like when you take a glass or a ebonite rod and rub it with silk or any fur-like substance, it generates electricity. It was generating electricity. It was creating charges, rather, I can say. The question was why this happened and why Dalton was unable to explain it. So with this question into mind, they came up with the conclusion that is atom indivisible? Is it indivisible? As Dalton said, atoms are indivisible. They further cannot be divided into any smaller part. Is this indivisible? Then if it is indivisible, according to Dalton, if this is true, then where from those charges came when glass was rubbed with fur? Or you can say when ebonite rod was rubbed with silk? Where the charges came from? Yes, these questions led to the discovery of atom. What is there in the atom? And with this, they came up with the conclusion that atom consists of certain very fundamental components into it. And those particles or fundamental particles were called as subatomic particles. They were called as subatomic particles. We need to first understand the subatomic particles, then we can move further. So they were called as subatomic particles, which were later termed as protons, electrons, and neutrons. So discovery of electron, it was being done by this discharge tube. This is the discharge tube, what you can see. And this discharge tube is also called as CRT. What does CRT stand for? Cathode ray tube. It also stands for cathode ray tube. Okay. So how the discovery of electron was done by this discharge tube? You can see here this discharge tube. This is a glass tube, cylindrical glass tube, which has got two metal plates at its terminals. One is cathode, negatively charged. Another one is anode. We call them as electrodes also. Then this is the vacuum pump to generate vacuum here. Entirely vacuum should be generated. Then a high voltage is applied for the power supply. Yes. And gas at low pressure is taken. Very low pressure. Okay. What is done is, now the question is, what is this discharge tube? This discharge tube, it is made up of glass, say around 60 centimeter long it is. It contains two thin pieces of metals called electrodes. Yes. And it is also known as Crookes tube also. The negative electrode is known as cathode and the positive electrode is known as anode. When gas enclosed at low pressure, now you may say how much low pressure, around how much into this, when you take gas of low pressure, say 10 raised to minus 2 to 10 raised to minus 3 mm of Hg pressure. So much low pressure when you take in this discharge tube. And when you apply a very high voltage, say 10,000 volts, 10,000 volts. Invisible rays were originating from the cathode. Some invisible rays were originating from the cathode. Yes, they are originating from the cathode. Now you may ask the question, invisible rays means how do we explain it? Invisible rays, these were passing from, they were originating from cathode moving towards anode, right? So since they were moving towards anode, at this point junction, what was taken was fluorescent material was being wrapped, and that was zinc sulfide material. Fluorescent material will emit light when any particles hit it, and there was a greenish yellow light, or you can say greenish glow was obtained below anode, behind anode on the glass, which was being coated with zinc sulfide. Yes, and therefore, since these rays were originating from the cathode, these rays were called cathode rays. Immediately, they did not come to the definition of electron, they denoted it as cathode rays. So, this was experimental setup. So, William Crookes studied the conduction of electricity through gases at low temperature. What he did, he performed the experiment in a discharge tube, which is cylindrical hard glass tube around 60 centimeter in length. It is sealed at both the ends and fitted with two metal electrodes. One was cathode and another one was anode. Cathode was negatively charged, anode was positively charged. The electrical discharge through the gases could be observed only at very low pressures. How much pressure I said? It was around 10 raised to minus 2 to 10 raised to minus 3 mm of Hg, and at a very high voltage, say 10,000 volts. Okay. And here two metal electrodes were cathode, which was negatively charged, and anode, which was positively charged. The pressure of different gases could be adjusted by evacuation. Vacuum pump was taken. When sufficiently high voltage is applied across the electrodes, current starts flowing through a stream in the form of stream of particles moving in the tube from negative electrode, that is cathode, to positive electrode, and these were called cathode rays or cathode ray particles. It was a stream of particles, students. Yes, and how all these questions were answered? They were answered very easy, properly, and those were clubbed as properties of cathode rays. So what are properties of cathode rays? Yes, the properties. The first one, cathode rays travel in a straight line. Now the question arises, the rays were invisible, then how can we say they travel in a straight line? What was done is, you can see here, when this discharge tube was taken, it was found that the rays were originating from cathode and they were moving towards anode. And the first property says cathode rays move in a straight line. How they came to the conclusion that they move in a straight line? When they went and hit the zinc sulfide screen here, the sparks were produced in a straight line. Therefore, they came to the conclusion that these cathode rays traveled in a straight line. Yes, they produce a sharp shadow, you can say, of solid object in their path, suggesting that they travel in a straight line. Yes. Now, second point, they were invisible. So how can I say that they are stream of particles? Stream of particles. Yes. What a scientist did was, he placed a rotating wheel here like this. And he found that when these particles were moving, the wheel started rotating. See, if it was only one or two particles, the wheel would have just moved, but it started rotating in this direction. What does that mean? It meant that the particles were in the form of, they were continuous. So they came to the conclusion that they were stream of particles. Yes, cathode rays, which were originated from cathode, they were stream of particles, right? Second, cathode rays start from cathode and move towards anode. They originated, it was found that they were originating from cathode and they were moving towards anode. These rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials. Which material did the scientist use? Fluorescent material, or you can use phosphorescent material. Both the materials will glow when any particle hits it. Okay. Cathode rays consist of negatively charged particles. Now the question is how they got to know that it consists of negatively charged particles. See, the rays were originating from cathode and moving towards anode. They were getting attracted towards anode, right? They were moving away from cathode. So they are getting attracted towards anode means anode is positively charged. Therefore, unlike charges attract. Correct? And like charges repel. So unlike charges are attracting means, and towards the anode it is getting attracted. That means these particles contain what charge? They contain negative charges. So what, apart from this also, what they did was they placed two metal plates here. These rays were expected to travel in what? They were expected. So I'll show you like this. So these rays, they were being expected to travel in a straight line, right? They were being expected to be traveling in a straight line, and they were moving from cathode to anode, stream of particles. Now, what the scientist did was he used two metal plates, electric plates. This was positive, this was negative. Yes, he found that when he placed these two electric plates, the rays were not moving in a straight line. Instead, they showed a slight deviation like this. They showed a slight deviation like this. They are showing deviation, attraction towards positive plate. That means the rays were negatively charged. That was the conclusion. Negatively charged. Even not only electric plates, the scientists also placed the magnetic plates also. Yes, north and south pole, to see the deflection. Only in absence of any electric or magnetic field, they were moving in a straight line. So when the electric field is applied on cathode rays with the help of pair of metal plates, these are found to be deflected towards the positive plate, indicating the presence of negative charge. So the characteristics of cathode rays do not depend on the material of electrodes and nature of the gas. Further, what the scientist did was he changed this material of what it was made up of glass, and he changed the material, and inside gas what he had taken, he used different gases. He found that the cathode rays did not show any change. The characteristics of the cathode rays did not get any change when he changed the gas. So he came to the conclusion that the cathode rays, characteristics of the cathode rays do not depend upon the material of the electrodes and nature of the gas. Nature of the gas. Yes. So these were some of the properties of cathode rays. Then these cathode rays, he termed them as electrons. He termed them as electrons. Yes, be negatively charged particles present in the atom. He termed them as electrons. Now, electron carries some charge and has some mass. So determination of charge to mass ratio, it is E by M. Okay, not L. Charge to mass ratio for electrons. How it was being determined. Okay. What J.J. Thomson did was, this was done in the year 1897. Cathode rays were discovered in the year 1879. Okay. In the year 1897, Thomson measured E by M ratio. See, the amount of deviation of the particles from their path in presence of electric and magnetic fields depends upon what factors. Thomson came to some conclusion. He said, greater the magnitude of charge on the particle, greater is the interaction with the electric or magnetic field. Yes, if negative charge is more, it will interact more strongly with the positive plate of the electric field or pole of the magnetic field. Mass of the particle, lighter the particle, greater the deflection. Yes, if it is very light, it will show greater deflection. If it is heavy, it will not deflect much. Yes, the deflection of the electrons from their original path increases with increase in voltage across the electrodes. That is, when you increase the voltage from 10,000 to more, the deflection also increases. So it depends on three things. One was charge, that is magnitude of charge on the electron, mass of the particle, and next was strength of the electric or magnetic field what you have taken. So when only electric field is applied, the electrons get deflected. When you apply magnetic field, they show some deflection. What this Thomson did was he balanced electric and magnetic fields. So he balanced these two fields and allowed the electrons to hit the screen. He observed that the electrons moved still in the straight direction. Yes. In the absence of in the absence of electric and magnetic field, the electrons were moving, cathode rays were moving. Similarly, when he balanced electric and magnetic fields, these electrons moved in the straight direction. So using this concept, he calculated the E by M value. What is this? Charge to mass ratio of an electron, and it came out to 1.758820 into 10 raised to 11. 10 raised to 11 coulombs per kg. Yes, this is the charge to mass ratio of an electron. E by M 1.758820 into 10 raised to 11 coulombs per kg. Yes, where Me is mass of the electron, in kg and E is magnitude of charge in coulombs. Yes, so this was how he came to the conclusion. You need to remember this value, charge to mass ratio. Then, if you know charge to mass ratio, that is E by m of an electron, 1.758820 into 10 raised to 11 coulombs per kg, then can we calculate only the charge? Yes, we can calculate the charge. And this experiment was being done by the scientist R.A. Millikan. It was being done by R.A. Millikan. Yes, that experiment is known as oil drop experiment. It is known as oil drop experiment. What it is was there, I'll just give a brief explanation there. Oil droplets in the form of mist produced by an atomizer. They were allowed to enter through a tiny hole in the upper plate of the electric condenser. The downward motion of these droplets was viewed through the telescope. When these were moving downward, the rate of fall of these droplets, Millikan, what he did, he was able to measure the mass of the oil droplets. Yes, the electrical charge of these oil droplets was acquired by collision of the gaseous ions. So Millikan concluded that magnitude of electric charge, I can say like this, magnitude of electric charge, say Q, is nothing but N into E. That is, it is always an integral multiple of electric charge. Integral multiple. How many? Of electric charges, where N can start from 1, 2, 3 and so on. So using this, he calculated the charge on an electron. And charge on an electron was minus 1.602 into 10 raised to minus 19 coulombs. So once you know E and you know E by M, can we calculate mass? So mass of the electron is E by M, right? So this is 1.6022 into, or you can keep it as 1.602 only, divided by 1.758820 into 10 raised to 11. That comes out to this value. See the value. 9.1 into 10 raised to minus 31 is a very, very, very negligible value. So almost we can say negligible. So almost we can say mass of electrons is 0. Almost 0. So negligible means what? Almost 0. Mass of electrons is almost 0. So this was the explanation what Millikan gave. Millikan gave a very, very, very fantastic what you say knowledge to us through his oil drop experiment. He determined the charge on the electron and even mass of the electron. So mass of the electron value magnitude, if they ask you, it is 9.1 into 10 raised to minus 31 kg. Almost negligible. When you compare it with relative masses of other particles, it becomes 0 only. And charge on an electron is minus 1.602 into 10 raised to minus 19 coulombs. Yes. So that is the charge on the electron. Okay. Now the question was discovery of proton. Now you may say how protons were thought to be present. If there were some of the particles moving, originating from cathode to anode, then definitely there might be some particles which are moving in opposite direction. Yes or no? So what this led, so cathode rays, they were first produced by the material of cathode and then from the gas inside the discharge tube due to bombardment of the gas molecules. How this anode rays were produced? See, this anode rays, what Saint Goldstone, this was being given by Goldstone, scientist Goldstone. What he did is, he did not change the experiment. He used the same experiment. The only thing what he did is, he used the perforated cathode. Perforated cathode. That means the cathode was having holes. What he wanted to see is, if there are particles moving in this direction, there must be some particles which are moving in opposite direction. Yes. And if there are particles, they will move through this, pass through these perforations and hit the screen. And here he coated with zinc sulfide to find the glow. Yes, any of the material can be used. So since the whole atom as a whole is electrically neutral, right? Atom is electrically neutral. There is neutrality maintained, neither positive nor negative. So if atom contains negatively charged, then surely there must be positive charge in it. And that positive charge will move in the opposite direction. Yes. Okay. Therefore, it was thought that some positively charged particles must also be present in the atoms. So, what Goldstein designed was he just modified the cathode. He modified the cathode. And successfully, he discovered the new rays called canal rays. He called them as canal rays for the first time because the rays were passing through these perforations, through these canals, through the holes. So, he called them canal rays. So the name canal rays, in fact, the rays traveled in a straight line through the holes. Okay. They were also called as anode rays because, not because they were originating from anode. Cathode rays, they were originating from cathode and reacting with the gas. But anode rays, they were moving away from anode. They were moving away from anode. Therefore, they were called as anode rays. They were called as anode rays. So this was the experiment to discover anode rays. So what Goldstein did? He modified the discharge tube by using perforated cathode. On reducing the pressure, he observed a new type of luminous rays passing through the holes, or you can say perforations of the cathode, and moving in a direction opposite to cathode rays. These rays were named as positive rays or anode rays or canal rays. Anode rays are not emitted from anode, students, but they were from the space between anode and cathode. They were moving away from anode, therefore they were called as anode rays. Please students, this is I am repeating again and again. Cathode rays were originating from cathode, reacting with the gas particles. So the name came cathode rays. But anode rays, they were not originated from anode, they were from some space in between anode and cathode. Okay. So what are the properties of anode rays? Even we can quote the same properties in the beginning. Anode rays also travel in straight line. Yes, they hit the zinc sulfide screen in a straight line. So they were traveling in a straight line. Then these were also made up of particles. You can say heavier particles. Okay, this was the conclusion. Heavier particles. These were carrying positive charge. They were carrying positive charge because they were moving away from anode. Why we say they were carrying positive charge? They were moving away from anode. Yes. Another way how you can explain this is, see, they are moving. What Goldstein did? He used metal plates, electric plates, positive, negative, and he found that the rays which were traveling in a straight line, they bent towards like this, negative plate. That means these rays were positively charged. They were positively charged. The value of positive charge in coulombs on the particles constituting anode rays is dependent upon the nature of gas. In cathode rays, it was independent. Whatever the gas you have taken, it was independent of nature of gas. But here, it was dependent on the nature of positive charge. The smallest value was obtained for hydrogen gas. He obtained the smallest value for which gas? Hydrogen gas. The charge to mass ratio of the particles is found to depend on the gas from which these originate. It was dependent. It was not fixed. Like for cathode rays, it was E by M value of an electron was 1.75820 into 10 raised to 11 coulombs per kg. It was not fixed for anode rays like this. It was dependent on the gas. You change the gas, E by M value was changing. Okay. Some of the positively charged particles carry multiple fundamental units of electric charges. That means in some gases it was found they were carrying +1 charge. In some gases it was carrying +2 charge. In some gases it was carrying +3 charge. So that was multiple. Yes. The behavior of these particles in the magnetic or electric fields is opposite to that of electron or cathode rays. Yes, cathode rays got attracted towards positive plate of electric field. Anode rays got attracted towards negative plate. Yes, and those anode rays, they were termed as protons. They were termed as protons. So what do you mean by protons? The smallest and lightest positive ion, it was obtained for hydrogen and was called protons. From that, the term protons originated. Yes, they were called as protons. Mass of the proton when calculated, it was 1.676 into 10 raised to minus 27 kg. And charge was same, value was same, but it was plus 1.602 into 10 raised to minus 19 coulombs. Yes, this was the mass and charge on the protons. Moving to the next one, that is discovery of neutrons. How neutron was discovered? See, this is a very big question. You can see 1879 proton electron was discovered. Then around 18 some 97 around, proton was discovered. This was electron, this was proton. See, neutron was discovered in 1932. Very long period gap is there because atom was neutral. First discovered was proton, electron, negatively charged. Then to make atom neutral, there must be something which should be opposite, so positive charge. So for many years, it was thought that only these two subatomic particles existed, electrons and protons. But when the mass of atom came into consideration, electrons are negligible. So entire mass of an atom should be because of protons. But it was not so. It was a bit more than that. Therefore, that led to the discovery of neutrons. It was being discovered by James Chadwick. It was being discovered by James Chadwick. What he did was, James Chadwick in 1932, he observed that when a beam of alpha particle, yes, alpha particle means it is having 2 units of charge and 4 units of mass, just like helium atom. When it bombards with the beryllium atom, beryllium, you know, it is 4 and 9, right? When it hits the beryllium atom, a new particle was ejected. The new particle ejected it was containing 7 units here. Then here it was 14. What was that? It was nitrogen atom. Plus, how much remained? 4 plus 2, it should be 6, sir. Okay, in case of beryllium, when it was bombarded with beryllium, it was not this atom, I'm sorry. When a fast moving alpha particle was bombarded with beryllium, he got this particle. So 2 plus 4 is how much? 6. This is balanced. So there was one more particle which was ejected. So it was not having, it was 0 here down. Charge, correct? 4 plus 9 is 13. Here it was 12. So upper side mass is 1. So it was neutral and relative mass was same as that of proton. So it was nothing but it was a neutral proton. We know protons are positive, but this particular a particle was neutral, same as proton, and therefore it was termed as neutron. Neutral proton was termed as neutron. Yes. So mass of the neutron, if you see, it is almost same as that of proton. How much is mass of proton? 1.676, and mass of neutron is 1.674 into 10 raised to minus 27 kg. And what is the charge on proton? It is 0. So mass of proton is almost same as that of neutron, but charge on neutron is how much? It is 0. So this led to the discovery of neutrons. So basically there were 3 subatomic particles, the fundamental particles present in an atom. Which were they? Protons, neutrons and electrons. Location we know now. In those days, location was not fixed. Today, we know with all the different theories, we get to know that protons and neutrons are present in the nucleus of an atom. Electrons are present outside the nucleus, right? What is the charge? Charge on proton is plus 1.602 into 10 raised to minus 19 coulombs. What is the mass of proton? 1.67 into 10 raised to minus 24 grams. Kg means minus 27 you can take. So if you take atomic mass unit, it is almost 1. Neutron, it is present inside the nucleus. Charge is 0. Neutral particle. Mass is almost same, 1.67, or you can keep it as 1.68 into 10 raised to minus 24. And relative mass is 1. Electron, charge is minus 1.602 into 10 raised to minus 19 coulombs. Mass 9.11 into 10 raised to minus 28 grams, or 9.1 into 10 raised to minus 31 kg. And mass is, see there, it is almost 0. Relative mass, you can take it as 0 only. So only when you are representing protons, electrons and neutrons, how do you represent proton? We write P charge is plus, mass is plus 1, charge is plus 1 and mass is 1. Yes, relative mass is 1 here. Neutron, charge is 0, n 1. Almost same as proton. Electron, minus 1, e 0. Yes, minus 1 charge, electron, and 0 stands for mass, negligible mass. So this is the subatomic particles. Now, once the subatomic, see, after the discovery of two subatomic particles, that is protons and electrons only. Okay, the neutrons were not discovered yet. All of them started an attempt to explain how the atom might look like. And the first attempt was made by Thomson's model of an atom. J.J. Thomson made the first attempt, and that was called as Thomson's model of an atom. So what this Thomson did, what actually he did was, his model is also called as watermelon model. I'll tell you why. Thomson, who discovered electron, was the first one to suggest the atomic model for atoms. Okay. He said all atoms contain electrons. Atom as whole is neutral. Yes, the total positive charge should be equal to total negative charge to make it neutral. So what he did was he visualized all positive charge of an atom being spread uniformly throughout the sphere like this. Yes, you can see here. This sphere, entire sphere, it is not hollow, okay? It is not like a football, it is like a shot put. Just like your watermelon, red part of watermelon. So it is distributed all over the sphere. What is this? It is positive charge. Positive charges are not present like this. This entire thing is positive charge only. This is positive charge. Just like your watermelon. Watermelon. Yes, the red part of watermelon is positive charge. He said it is distributed uniformly. The positive charge is distributed uniformly throughout the sphere. Approximately, he mentioned the diameter, say 10 raised to minus 10 meters diameter. Okay. Then he said the electrons were small particles. They were carrying negative charge and they have to be equal, right? So these electrons were embedded in the positive charge. The electrons were, I'll write it here, the electrons were embedded in positive charge. Now, what do we mean by embedded? See, watermelon you have seen the seeds. Are the seeds present only on the outside part, or are they present only inside? They are present all over the red part of the watermelon, right? So seeds represent what? Electrons. They are embedded. We use the term embedded. So positive charge is present as uniformly distributed as a sphere of say diameter 10 raised to minus 10, and negative charge, which has to be equal to the positive charge, the electrons, they are embedded in the positive charge. They are embedded in the positive charge. So the charge distribution, it was almost it gave the stable arrangement, yes or no? According to him, that it gave the stable arrangement. He was correct with his concept. So this model of atom, it was also called as plum pudding model. So when you order a pudding, you will see plums in it, resins in it, right? They are present all over. Same like your watermelon. Just imagine watermelon for it. So it was called as plum pudding model. So Thomson's model of an atom. So what he did, he proposed that atom may be regarded as a sphere of approximate radius, say 10 raised to minus 10 radius, it is said, carrying positive charge due to protons and in which negative charged electrons are embedded. In this model, the atom is visualized as a pudding or a cake of positive charge with electrons embedded into it. You can call it as a watermelon model also. The mass of atom is considered to be evenly spread over the atom according to this model. So what he said, the entire mass of an atom is distributed evenly throughout the atom. So his conclusion was the mass of the atom was only because of the electrons. That was the only mistake what Thomson did. Yes. So drawback of Thomson's model was this model was able to explain overall neutrality of an atom. No doubt it was able to explain overall neutrality. Positive charge, the same amount of negative charge. But it could not satisfactorily explain the results of scattering experiment which were carried by Rutherford. Rutherford carried an experiment. We'll discuss what it is. He could not explain the results which he got. Yes, we're using this experiment. One more thing, what he said, the entire mass of an atom is because of electrons. And we know that electron mass is negligible, it is zero. Something 0.0006. Yeah. So if this has to be entire mass of an atom is should be because of electrons. Today we know it is because of protons and neutrons, right? He said it is because of electrons. If that was true, then the smallest and the lightest element, atom of the element, which one is that? Hydrogen, according to him, should have 1837 electrons. Because if you want a mass of one proton mass, it is equivalent to 1837 electrons mass. When you take 1837 electrons, the mass of those many electrons will be equal to mass of one proton. That would have happened. So the lightest element would have how many electrons? These many electrons, which is impossible. Which is impossible. Yes. So this theory got failed due to these two reasons. Yes. So with this came the emergence of next model, an excellent model which was being given by Rutherford. Rutherford's alpha particle scattering. Alpha particle scattering experiment, which was also called as Rutherford's gold foil experiment. Okay. So what did Rutherford do? In 1911, he performed some scattering experiment in which he bombarded the thin foils of metals like gold, silver, platinum, copper. Now, I may say why he used these metals only, which are so costly, right? See, metals in general are malleable, and the most malleable metal is gold. That means when you hit that gold, it becomes the thinnest sheet. So that's the reason this gold was considered. So he used gold only. So it is called gold foil experiment. So the thin gold foil had a circular fluorescent zinc sulfide screen. Now, why zinc sulfide screen was he used? If any particles are there, invisible particles, if they hit the zinc sulfide screen, we want to see the glows. That's it. When alpha particles are struck the screen, a tiny flashlights were produced at that point. And from these experiments, he made the following conclusions. So what conclusion? So look at this. This was the experiment what he did. So what he used is he used a radioactive source here into the lead block. Lead block will not allow the rays of radioactive substance to come out. What is a radioactive substance? Which emits rays on its own. Emits rays spontaneously. It gives alpha rays, beta rays, gamma rays. Alpha rays, we are going to use Rutherford used alpha rays. Yes. So let me tell you, it has 2 units of positive charge, and its mass is 4 units. So it is heavy. Remember this information what I have given. Okay, fine. He used here into the lead block, and he made a small slit here so that the rays pass here. And these are not just 4 or 5 rays. He passed around 20,000 rays at a stretch. Around 20,000 rays. Where he passed, he made them to hit the gold foil. And see, around the gold foil, he had taken a circular fluorescent material that was zinc sulfide material. Yes, zinc sulfide material, right? Okay, he started the experiment and he came with 3 conclusions. These were the 3 conclusions what he came to. What were the conclusions? He found that out of 20,000 rays, most of the rays went undeflected. See here, all the glows were produced here only. So most of the alpha particles, they traveled through the foil undeflected. They passed in a straight line, yes or no? They passed in a straight line means what? They went undeflected. Okay. Second observation was this, and this is the second observation. Some alpha particles deflected by small angles. This is small angle made. Some alpha particles showed minor deflection, I can say. Minor deflection. They got what you can say repelled minorly, not very much. Okay. And see this. It almost rebounded back, right? it almost rebounded back. So out of 20,000 rays, there is only one ray. So occasionally only one alpha particle rebounded back. It traveled from the gold foil in opposite direction. That means it repelled completely. I can say that. Okay. So these were the observations made by Rutherford in his gold foil experiment. So what was the observations? It is not a particle, it is alpha particle. Most of the alpha particles pass through the gold foil without undergoing any deflection. This one. Most of the alpha particles, first observation, they went undeflected. A few particles underwent deflection through small angles. So that was minor deflection. The B observation, what we have seen. Then very few more mere deflected back. Hardly 1 out of 20,000 rays you can say, making an angle of 180 back. So from these observations, what conclusion he came to? What interpretation he made? With the first observation, he said that, see, something is moving undeflected means, suppose you are going from your home to, you are going from your school to college to your home, you are moving in a proper straight line on the road. If there is nothing present, if there is no obstruction present in your path, you will still move in a straight line, right? But if there is a big pit being done by the municipality, what you will do? You will make a small deflection. But if the pit road is only closed, what you will do? You will get back and find a different road. Understanding? In the similar way, the most of the alpha particles pass through the gold foil undeflected mean was there was no obstruction for the alpha particles. Yes. So I can say most of the space in an atom is empty. So most of the space in an atom is empty. Atom is mostly having empty space. Some alpha particles deflected by minor angles. Yes, might be the alpha particles have come across some obstruction. Suppose this is an atom. Might be these alpha particles have passed like this. The alpha particle has come across some obstruction. Now what is that obstruction? Can I say here there is some pit? No. Alpha particles are what basically? They are positively charged. They are getting repelled means what? There must be some negative charge here. Yes or no? Alpha particles are positively charged. Yes. So there must be some negative charge here. So it is getting deflected. Is that right? No. If it is negative charge, it would get attracted. So alpha particle is getting repelled means what? There must be something which is positively charged only, because like particles repel. Like particles repel. So there must be something which is small also, because not very large number of particles are getting repelled. So there must be positive charge which is small, and therefore it is getting repelled. This is second case. So nucleus, okay, let me not use the term nucleus now only. Then further third observation was hardly 1 out of 20,000 rays showed bonded back. Now this positive charge, which is very small, must be heavy. So only the alpha particle with 4 unit mass is getting rebounded back. Because of positive charge, it is repelling. But it is rebounding back means what? It is very heavy. And only one particle is getting rebounded. That means it is very small. Yes. So Rutherford concluded that in an atom, most of the space is empty and there must be something very small. There is some body which is very small, extremely small, positively charged, and it is heavy, present in the atom, and he called it as nucleus. He was the first one to term nucleus in an atom, and therefore Rutherford's experiment is called as Rutherford's model of an atom is called as Rutherford's nuclear model of an atom. It is called Rutherford's nuclear model. Cleared? So these were the observations and interpretations what he came. Since most of the alpha particles pass through the gold foil without undergoing any deflection, there must be sufficient empty space within the atom. So atom consists of empty space. A small fraction of alpha particles was deflected by minor angles. The positive charge has to be concentrated in a very small volume that repelled and deflected a very few positively charged alpha particles. So this very small portion of the atom was called nucleus. The volume of the nucleus is very small as compared to the volume of the atom. When you compare it to the volume of the atom, the volume of the nucleus is very small. This was the explanation. So see, they were going undeflected. Yes, they were going undeflected means what? Nothing is there in their place. But when the alpha particle is moving here, it showed the small deflection. So positive charge, positive charge. So there is slight repulsion. When alpha particle is moving exactly at the center, it is concentrated at the center, the positive charge. So it turned back. Yes, so this is the movement of alpha particles, and this is the gold foil, and these are the deflections. Yes, this was Rutherford's model. Conclusions, what he came to. So with this conclusions, he came to the postulates, you can say, of Rutherford as Rutherford's nuclear model of an atom or Rutherford's atomic model. So what he said was, Rutherford said was, you consider any atom, it consists of tiny positively charged nucleus at the center, and it is surrounded by hollow empty portion called extranuclear part. So he said any atom, it consists of, it is like this, any atom, it consists of tiny positively charged, yes, tiny positively charged, so this is positively charged nucleus. So he termed it as nucleus, and it is surrounded by hollow portion, and this hollow portion he termed it as extranuclear portion. Extranuclear portion or extranuclear part. Okay. The positive charge of the nucleus is due to protons and neutrons. The positive charge is due to protons. Okay. And the mass of the nucleus, so positive charge is due to protons. Mass of the nucleus is due to protons and neutrons. Yes, and the electrons are present in the extranuclear portion. This was all explained by Rutherford. So positive charge of the nucleus is because of protons. Mass of the nucleus is because of protons and neutrons, and which were together called, they were together called nucleons because they were present in nucleus. And electrons being negatively charged, they were revolving around the nucleus. Yes, because they have negligible mass. The atom is electrically neutral as the number of protons is equal to number of electrons. If there are 10 electrons, there will be 10 protons. If there are 20 electrons, there will be 20 protons. Yes. Thus, the total positive charge of the nucleus is balanced by total negative charge. Okay. So, how much positive charge is there for the nucleus? That is being balanced by total negative charge of the electrons. And these electrons, they were found to revolve. So, if you consider this as an atom, and if you say this is a nucleus, okay, so the electrons were present in extranuclear region. Okay, so the electrons were present revolving around the nucleus in these imaginary paths, and those imaginary paths were called orbits. They were called orbits. So atom resembles like your solar system. Sun is the nucleus, and all the planets revolving around the sun are our electrons. So therefore, Rutherford's model is also called planetary model. Planetary model. Yes, electrons and neutrons. So here are electrons, protons are present inside the nucleus. So protons and electrons, they are held by electrostatic forces of attraction. They are held by electrostatic forces of attraction. So these were the what you say conclusions, or you can say postulates made by Rutherford in his model. Okay. So these forces of attraction, they are which are operating on the electrons, they are balanced by the centrifugal forces. Centrifugal forces. So that is about the nuclear model of atom which was proposed by Rutherford. Not only in this, Rutherford has made a lot of research in the field of nuclear science. Therefore, Rutherford is called the father of nuclear chemistry. is called the father of nuclear chemistry. But still, with all this explanations also, there were drawbacks. Today, what model we see of an atom is not Rutherford's model. Now, why it is so? Why? What is the reason? See, the reason is, first point, when a body is moving in an orbit, it achieves acceleration. The body can be a charged particle. So electron, it is moving around the nucleus in an orbit. So therefore, it is under acceleration. There is a theory called Maxwell's electromagnetic theory. According to this theory, charged particle, when it is accelerating, it will go on emitting radiations. That means it will go on losing energy, students. Therefore, an electron in an orbit will go on emitting radiations. That means it will go on losing energy. The energy carried by the radiations comes from electronic motion. So when it goes on losing energy, what will happen? The path will become closer to the nucleus. And ultimately, it will fall into the nucleus, right? Within 10 raised to minus 8 seconds, it will fall. But what Rutherford said, it will not fall. It does not happen. Yes, obviously it does not happen. Electrons will not fall into the nucleus. Rutherford said it does not fall, but he could not explain why it will not happen. Yes, therefore Rutherford's model cannot explain the stability of an atom if the motion of electrons is described on the basis of classical mechanics. Here is the explanation. You can see, any charged body, when it is revolving, it will continuously lose energy. That means it will continuously emit radiations. When it is emitting radiations, it is accelerating, right? It is accelerating. So since it is accelerating, it will go on emitting radiations. It will go on losing energy. Yes. When it goes on losing energy, it will go on falling nearer and nearer to the nucleus. Directly, it will not fall because it is revolving in a circular manner. So spirally, the acceleration, this is spiraling of the acceleration of electron. So with this same path only, it will go on losing energy, and ultimately within 10 raised to minus 8 seconds, it will come and fall into the nucleus. When it falls into the nucleus, what it becomes? It becomes Thomson's model. And we know that Thomson's model is not stable. This is according to classical mechanics. Yes, Maxwell's theory, electronic distribution theory. So Rutherford said it will not fall into the nucleus. Obviously, electron won't fall into the nucleus. But the question was asked why it will not fall into the nucleus, because classical theory was not wrong. Any accelerating body will continuously emit radiations. It will go on losing energy. So electron being a charged body, it is accelerating around the nucleus. It should also lose energy, and ultimately this charge will not get reduced. This charge is getting reduced. So spirally it will fall into the nucleus. Yes, and that's how the stability of atom gets disturbed. That was not being explained. Even Rutherford's model did not give any idea about distribution of the electrons. Electrons are present. He said electrons are revolving around the nucleus in certain paths called orbits. But how the electrons are distributed? Are all the electrons present in only one orbit, or there are different orbits? And if there are different orbits, what about the energies of the orbits? That all was not being explained by Rutherford. That all concept was not being explained by Rutherford. Therefore, Rutherford's model was not accepted again. It again came to the question was like, what was the model then preferred model for an atom? See, this was a very beautiful model given by Rutherford. Very nicely he performed the experiment, and he said that the entire space of an what were the conclusions? Yes, he came to the conclusion so beautifully. Positive charge and most of the mass of the atom was densely concentrated in an extremely small region, and that very small portion of the atom was called nucleus. So here I have skipped some of the points also. So what entire charge on nucleus? Charge on nucleus was because of protons. And mass of the nucleus, it is dense, right? Mass of nucleus was not just because of protons, it was because of protons and neutrons. Yes, which was collectively called nucleons. Collectively called nucleons, right? Collectively called as nucleons. So that small body positively charged, which is very heavy, it was termed as nucleus by Rutherford. getting lot many new applications and research in the field of nuclear chemistry. He was the one who was called as father of nuclear chemistry. As I said you, nuclear physics. He was called father of nuclear physics. Now, to make atom electrically neutral, atom is electrically neutral, right? Yes, this has not to be disturbed. We know atom is electrically neutral. To make it electrically neutral, the how much protons are there, the same number of electrons should be there. So where are these electrons present? They are revolving in certain imaginary paths called orbits, where in the extranuclear region, extranuclear part, they are revolving there. So to make atom electrically neutral, the number of protons is always equal to number of electrons. Remember, if there is an atom, say I have an atom and this atom has got 15 protons in the, I'm sorry, I'll write it here. So say here there are 15 protons, then how many electrons will be there? There will be 15 electrons to make entire atom electrically neutral, right? So then these electrons which are present in the orbits, which are revolving around the nucleus, they are revolving at a very high speed. They are revolving at a very high speed. Okay. Then the electrons and nucleus, or you can say the electrons and protons, they are held together by electrostatic forces of attraction. They are held together by electrostatic forces of attraction. So these were very important points. But far from this also, it faced certain drawbacks. And the drawbacks were, according to Maxwell's theory of electromagnetic theory, if a charged body is there, it is accelerating, it will go on losing energy. And electron being a charged body, negatively charged, and when it is revolving, we say it is accelerating. So it should also continuously lose energy. So when it is continuously losing energy, within no time, it will fall into the nucleus. When it falls into the nucleus, it becomes Thomson's model. And we know that Thomson's model could not explain the stability of the atom, right? So we say, according to classical mechanics, any charged body in motion under the influence of attractive forces should radiate energy continuously. If this is so, the electron will follow the spiral path. Can you look at that spiral path? Spiral path, and finally fall into the nucleus, and the structure would collapse. So this behavior is never observed, but Rutherford said then electrons never fall into the nucleus. Yes, today also we know the electrons do not fall into the nucleus. But why? Why then is it spoiling classical mechanics theory? No, classical mechanics theory cannot be wrong. That is proven theory. Why it will not fall into the nucleus was not being explained by Rutherford. It was being explained by another excellent scientist, that is Niels Bohr. So whatever limitations were present in Rutherford's theory, they were being upcomings were being found in Bohr's model of an atom. Even electrons were present. He said electrons are revolving around the nucleus. Agreed, in the orbits. But are the electrons how they are distributed? You call it, right? Electronic structure, we say. Electronic structure of atoms was not being explained by Rutherford. It was not being explained by Rutherford. So these were some of the limitations. So we have discussed about Thomson's, we have seen discovery of subatomic particles, that is electrons, protons and neutrons. The relative charges and masses we have seen. Then Thomson's model, what were the drawbacks? Rutherford's model, what were the drawbacks? Yes, with this, I will just stop my video here. In the next part, we'll be discussing the next part of the chapter. Yes, hope till here you have enjoyed the class. Thank you.